Welcome back. Welcome back to our protection, high voltage protection and relaying subject. Welcome to another lecture, online lecture. I hope you all are safe or all are healthy, and inshallah all this pandemic will finish ASAP, as soon as possible. Today we are going to cover the last section of the three-phase differential protection. In the previous two sections we studied single-phase differential protections, three-phase two windings, three-phase two windings differential protection. Today we are going to show if we have a transformer, three windings. Let's look at this transformer. I'm gonna assume this is a three-phase transformer. On this side I had two output. This is my transformer. I'm gonna say this is being connected into a three-phase system. I have transformer, three windings. Okay, I need to design the protection of this transformer. This transformer, because I have winding on the primary, two winding on the secondary. I have an input and I have two output on this case, or I could have two input, one output. How do I start the differential protection for this transformer? What I studied before, it's very important to me. I will follow exactly the same step. There's no difference. The CTs, let me get different color. The CT depend on the current. I have a current in here. Let's say I have a current in here, current output. This situation, I have a power source connected to the primary, and then I have a two output on the secondary side. This windings, because the input, this winding power should be equal to this power plus this power. Let's give an example. Let's say on this side I have 34.5 kilovolt, 500 MVA. Okay? On this side I have 500 kilovolt on this winding, 300 MVA. On this side I have 138 kilovolt, 200 MVA. 200 MVA. Okay? Now I need to distinguish what sort of transformer. Is it delta Y, Y delta? What sort of arrangement do I have in front of me? What sort of arrangement? I want to assume that this, pay attention to this. Okay. This system in here is connected as a delta, this winding connected as a Y, and this winding connected as a Y. Remember, I'm talking about three-phase system. Three-phase system. Perfect. The system will require how many CTs now? That's a three-phase. So I need three CTs on the primary. That's a three-phase. I need three CTs on the top winding, three CTs on the bottom windings. That's done. Same what I did before. No new information. Great. How do I connect my CTs? Remember, still the same concept. This winding connected as a delta, so therefore my CT will be connected as a Y. So now this CT in here, this CT in here, that goes down, this is my CT, I will connect my CT as a Y. Now this CT, I will have a CT in here and CT. This set of CT will be connected as a delta. This set of CTs will be connected as a delta. So I did not learn new things so far. So far, everything the same. Everything the same, whatever I learned. So if I have the power transformer winding as a delta, I connect my CTs on this side as a Y. And if I have the winding of the power transformer Y, I connect its CT as a delta, because I need to compensate for the 30-degree shift between delta and Y. I hope you still remember this from the previous video. Okay, how do I determine the CT ratio? I do exactly the same. There is no difference. I want you to know one element, one step. When it comes to the CT ratio, I will use 500 MVA as a power to calculate all the current. So what I do is, this current, what will be this current equal to? This current in here will be equal to 500 10 to the 6 divided by root 3 34.5 10 to the 3. For the sake of these two, I calculate the current in here using the 500. Why? I just want to get the CT ratio, so it doesn't matter for me. I just want to get the CT ratio. Okay. So this current in here, I can also use 500 10 to the 6 divided by root 3 138 10 to the 3. For this current, I will have 500 10 to the 6 divided by root 3 500 10 to the 3. Is that clear? No. I found this current, and I found this current. This current, because my CT connected to a Y, so therefore, straight away, I will know my network. So straight away, this answer is 8,367. 8,367 M. This calculation will give me. So therefore, from the CT, because it's Y, my CT ratio on the primary will be, I want to use 9,000 to 5 amps. Because that's why. When I come to delta, remember what we did previously. We have to, this current must be divided by root 3, because in a delta, remember this? This connected in a delta. This current will go to this Y, this current. I need the line current of the delta to be the same as this one, as the output of this. The output of this one will be equal to the output of this current of the CT. This is my CT on the primary, will be equal to 8,367 times 5 divided by 9,000. Divided by 9,000. Is that clear? That's exactly what we did in the previous examples. There's no changes at all. It's exactly the same what we did. So I end up with, let's do the calculation, 8,367. 8,367 times 5 divided by 9,000, 4.64. 4.64. So therefore, I need this current. That comes from the delta to give me the same ratio. Is that clear? Is that clear? And that's how I determine my CT ratio for the secondary part. That's how I determine my CT ratio on for the secondary part. For the secondary part. Is that clear? Because the reason why I want to consider that during my assessment, the worst case scenario, if this has zero, if has a zero output, this could have the entire output. If this has zero output, this could have the entire output. And I do exactly the same now. I found, remember, I'm doing it in the sake of CTs. So now I do exactly what I did before. I end up, if this is 577 amp, divided, I have to make sure that the system in here, I have a CT that gives me 577 as an input, goes into the CT, the output of the CT must be 2.68 amp, because this divided by root 3. This divided by root 3, 2.68 amp, and that's what I end up with the CTs. So now the CT ratio will be, 1000, in this case will be 1000 to 5, and the other one will be 3600 to 5. So this will be 1000 to 5, 3600 to 5 ratios. Okay. Before we finish this session, I want you to know one element. It is possible for me, let's sketch it in a different way. Let's sketch this in a different way. So I explained this final concept. Now, I have a transformer. On this side, I have 1 windings. On this side, I have 2 windings. This is my CT. This is my CT. This is my CT. In here, I have my differential relay. The system in here goes down. This one will goes down to this one, and this also will go down and will be connected to the same one. However, because this will be like this. So this current, I want to call this I1, I2, and I3. The differential will do I1 minus I2 plus I3. This I will use CT, 3 CTs at the front, 6 CTs on the secondary side, as we spoke before. It is possible under the following condition. It is possible to use a CT with 3 windings. So it is possible to use a CT where I have the CT could have 2 windings. Same as a transformer when I have a transformer of the 3 windings. It is possible to put this in parallel under the following condition. Pay attention. Under the following condition, I can parallel this together. If I have one output only in the circuit, and these are only an output system. So the source is only on one side. If I have a source only on one side, I can parallel the secondary. I can parallel the secondary CTs. It is possible for me that under this condition, a 2-winding differential relay can be used to protect the 3 windings, the 3-winding transformer. Under this condition, I can parallel it like this. However, if this has a source and this has a source, it's very dangerous to do it this way. The reason, if this has no input, I can create a fault in here because of the restraint, because of the inrush current, because of a lot of circulating current inside the system in here. I could have an issue, and I could cause a major problem to my network and a false tripping under conditions. What we will do now is we will take a few minutes break, and then we will solve an example to show why, if I have an input to source to the transformer, two possible sources to the transformer, I cannot use this parallel system. I hope that's clear. Let's take a pause and then we will continue with an example.